starting here where it says trigonometric form of complex numbers and de Maveray's theorem. So we're going to show you how to do something really, really, really cool. And for example, suppose I told you to take 3 minus I roots of 2, and I told you to take that to the 4,000th power. Could you imagine having to take that and multiply it out 4,000 times? How long do you think it would take you? A day? 2 years. Can we agree that it very well could take you at least a month? That'll be a long time, right? I would teach you how to do it tomorrow in 3 minutes. And that seems ridiculous, but it can be done. In order to do that, we have to teach you how to do this. So a couple of people got frustrated, like, why even? Well, the why is tomorrow. So we're going to teach you how to do that piece. The extension of trigonometry is to apply it to multiple pieces. Number 1, complex number analysis. Number 2, vector analysis. Anybody talk about vectors in a physics class? Got a couple people there. Number 3, conic sections, such as the motion of planets, okay, around the sun. And then on number 4 would be parametric and polar equations. So the whole piece about like easy math, that is done. If you want easy math, then stop taking math like today, okay? So here we are. Graphing complex numbers. What we want to do is we want to graph A plus BI. And so what I'm going to do is I'm going to show you a basic one. I'm going to graph the number 3. Do you see the number 3 that I plotted? Do you see how easy that is? So what I would like to do is instead of graphing 3, what if I want to graph 3 minus 4i? Well, where does that go on here? It has a real part, it has an imaginary part. Like this is called the real number line. So what do? We have a real number line and we have a imaginary number line. Together, it makes up what we call the complex plane. Leonard Euler developed the complex analysis piece. It changed our world. It definitely changed mathematics. One of the 4 greatest minds to ever walk the face of the earth. So, let's graph this first number. We use the letter Z to represent complex numbers. So Z sub 1, it says, is equal to 2 plus 4i. I'm going to graph it. I go over 2 units on the real axis. I go up 4 units on the imaginary axis, and I put a dot. I don't just put a dot. I then, from the origin, draw a segment to the dot. That is the graph of 2 plus 4i, or Z sub 1. Is that new? Yes. Is that challenging? No. Get my point? All right. Z sub 2, it says, is negative 1 minus 5i. Which quadrant will that place me in? So I go back 1 and down 5. No big deal. Y'all good? Now, let's graph Z sub 1 plus Z sub 2. Z sub 1 plus Z sub 2. So I'm going to take Z sub 1, which is 2 plus 4i, and I'm going to add that to negative 1 minus 5i. Can anybody tell me what I get when I add those 2 expressions together, Dr. Luke? 1 minus I. Which quadrant will that be in? The 4th quadrant. So, just to make a point, if you add the blue to the red, you apparently get the green. Doesn't that strike you as somewhat odd? I mean, it would seem if we added the blue to the red, you would get something maybe larger. It looks like it kind of divides it in half, but it is interesting. And the geometrical representation of these is something we won't get a lot of time to talk about, but this is the sum of those two. The next one, it says negative z sub I. I meant negative z sub 1. Negative z sub 1. Anybody want to know how? Anybody have an idea how I come up with negative z sub 1? Yeah, distributing negative, I get negative 2 minus 4i. So I'm going to go back 2, and I will go down 4. Good with that? Back 2, down 4. What do you notice about the black graph compared to the blue graph? It's in the opposite direction. Same length, isn't it? Yep. And then we have 1/2 z sub 1. If I do 1/2 of z sub 1, what are you going to get? Yep, 1/2 distributed, which is 1 plus 2i. So if you notice, if you go over 1 and up 2, that is the same as the blue graph. It is just the it's just a smaller amount, right? Is everybody okay with that? Okay. So right now you're kind of wondering, what the heck does trigonometry have to do with that, right? Trigonometry is all about sine, cosine, and tangent. It has far greater applications. And if I were to take a number, say a plus bi, and place it there, notice that it has length, say a radius, but it also has an angle of rotation. And so r and theta are things that we have talked about, haven't we? But before we define that, we would like to define what we call the modalist. The modalist is the absolute value of a complex number. So my daughter Tenley is now in 5th grade, sharp little kid, but there's a lot of things she doesn't know yet. If you were to describe absolute value to Tenley, how would you describe absolute value to her? How far it is away from 0. Agreed? Now, let's admit that you kind of think about it, you say just make it positive, right? That's kind of how you think about it sometimes, right? But the true definition would be to say, how far is it from 0? So let's use that same type of definition when we look at a complex number. I would say, how far is this from the point of origin? See that? So if I wanted to determine how far this was from there, how would I do that? This length is A, this length is B. Right? So, somebody. Nothing to do with theta. Pythagorean theorem. Thank you. A squared plus B squared is equal to that distance, we'll say R squared. And so therefore, the absolute value of a complex number is the square root of A squared plus B squared. That's trigonometry, right? A squared plus B squared. Definitely done that before. So the first question is find the modulus of Z1 and Z2. So Z sub 1 is equal to, or the absolute value of Z sub 1 is equal to, the absolute value of 2 plus 4i. And the absolute value of 2 plus 4i, how do we determine that? Well, we make a square root, and we square a to get 4, and we square b to get 16. And 4 plus 16 is? And the square root of 20 is 2 roots of 5. Could you do that on the test? So understand my horror when people get to that spot and they can't do it. We all good? So notice that we have a complex number of a plus bi, but that distance is not bi, it's just simply b. We just use that number to determine the distance. So the I has nothing to do with that. It just tells us we're on the imaginary axis. Absolute value of z sub 2 is going to be the absolute value of negative 1 minus 5i. How do I do the absolute value of negative 1 minus 5i? Square root of, which is 26. So I get the root of 26. Beautiful. Nothing too challenging yet, right? All of it is pretty straightforward, but all of it is new, right? Okay, so let's flip it over and let's look at this piece. So our goal is to get through example 3, and then we'll be done with today. So if we want to determine, as I said before, something like 1 minus I roots of 3, we want to take that to, say, the 700th power, or let's just go 7,000, okay? That seems rather difficult, doesn't it? We're going to make that easy. In order to make it easy, we have to be able to place complex numbers in what we call trigonometric form. Again, we're going to do it today. You won't see the purpose for it until tomorrow. So let's understand what we're doing. We have this complex number, which is a plus bi. And I already showed you that if we take this and turn it into a triangle, whoop, there we go. We're going to call this a length of A. We're going to call this a length of B. We're going to call this R. And we're going to call this theta. So, Patty, you can kind of use some of the thoughts you were trying to use earlier as we calculate this, because you're on the right track. So if I have A plus BI, what I want to do is I want to get rid of A and B. I want to turn it into a new form. So who out there can tell me what deals with R, theta, and A? Cosine. Everybody agree cosine is going to be the adjacent divided by the hypotenuse? So therefore, we write the cosine of theta is equal to what? A over R. I can solve for A by multiplying both sides by R, like a pirate. Good. I would like to get rid of B. What trig function has to do with R, theta, and B? Sine. Namely, the sine of theta is equal to your B value divided by R. What can I do to solve for B? And I get R sine of theta is equal to B. Notice now I have something for A and I have something for B. So let's write it. I have R cosine of theta plus R sine of theta times I. They both have an R. What could I do if they both have an R? Factor out an R. R times the cosine of theta plus, and I'm going to put the I in front of sine so we don't think it's the theta times I. So I sine of theta. So this is complex form. This is trig form. In order to go from complex to trig, we need to determine two things. Number one, we have to come up with R. Who can give me an equation to come up with R? Square root of A squared plus B squared. Theta, we have to come up with as well. So let's consider theta. What trig value or what trig ratio has to do with A, B, and theta? Tangent. So namely, you use tangent of theta is equal to the B value divided by the A value. And we solve for theta. We good? Okay. If If we can't do these three, then we're going to struggle the next 2 days. So let's make sure we get it, and we're good to go. These are complex numbers. They need to be moved from this form into this form. I have to determine 2 things. What 2 things do I determine? R and theta. How do I determine R? Square root of a squared would be 4 plus 4. So I get the square root of 8, which is, as you said, 2 roots of 2. In order to determine theta, I set up an equation. Tangent of theta is equal to what? 2 divided by 2, which is 1.
We're not calling I for finding theta.
No. Where is tangent positive? 1 and 3. I'm not looking at both quadrants. I'm looking at only one of them. Pair and share for 20 seconds. Do you think I'm going to use the first quadrant or the third quadrant, and why? Go. Five, 4, 3, 2, 1. What do you think? I am going to use the first quadrant because if you're going to graph this coordinate, if you're going to graph this complex number, is it going to end up in the first or the third? See how this ends up in the first? That's why we use the first quadrant. Where is tangent equal to 1? How would you find that out? We just use our calculator, right? Tangent inverse 1. You're right, Patty. It is 45 degrees. I picked a nice number for us to start with. We'll try that again. Tangent inverse 1. For those of you who didn't know, tangent's equal to 1 at 45. There it is. You see that? Now, anytime we use complex numbers, it's not as helpful for us to use degrees. It's much more helpful to use radians. So what is 45 degrees in radians? Pi over 4. Good. So I have R and I have theta. So now I'm going to write it in what we call trigonometric form. Your R value is 2 roots of 2 times the cosine of pi over 4 plus I sine of pi over 4. I have seen questions on the ACT involving that. I get that it looks ridiculous. The challenge is for you the next 2 days to see why it is so cool and amazing. Because for myself, I'm still, every time I do it, I'm amazed. It's incredible as we continue to use it. Everybody okay with how I came up with that? We determined R, we determined theta, we dropped the values in. That's it. You see that? Okay, now I want to show you something that's going to kind of be cool for you, okay? This should connect. Don't write this down, but watch. I have 2 roots of 2 times, what is the cosine of pi over 4? Root of 2 over 2. Okay? Plus I times, what's the sine of pi over 4? Root of 2 over 2. Watch what happens when you distribute here. What's going to happen to the 2 and this 2? They cancel to get 1. And what's the root of 2 times the root of 2? 2. And then here you also get 2, right? When you distribute back through, what do you get? You get what you started with. We transferred from one to the other. So many people don't see that relationship. It's like, okay, so there you go. Yep. If you ever want to check your answer on the test, simply just multiply it back through, and you should get what you started with. You should be able to check every single result. Okay, let's do a second one. You guys are doing very well, but you're quiet. If you have a question, please interrupt me so we can talk about it. This should be written as -3 plus 3i roots of 3. I forgot to put the I in there. Sorry about that. I make mistakes. I am human. One is good. People say funny things to me all the time. Okay, so let's figure out R. How do we figure out R? Square root of? What is a squared?
9.
9. Please do not ever put a negative number underneath here, folks. That's one way to drive me nuts when I grade your test, is that you're still squaring and getting negatives. What if I square 3 roots of 3? 3 roots of 3 squared.
27.
27, how'd you get that?
Because 3 times 3 is 9, and then the root of 3 is, yeah.
Yeah, so 3 squared is 9, root of 3 squared is 3, 9 times 3 is 27. Good. And so you get the square root of, which is 6. Good. Not too bad, right? We're still just doing a squared plus b squared. All right, now we find theta, which is no big deal because you guys have learned how to solve equations. I say tangent of theta is equal to what? Don't use the I. 3 roots of 3 over negative 3, which is what? Negative root of 3. Where's tangent negative? 2 and 4. Which quadrant am I working in, 2 or 4? Why? When you plot the graph, you'll be in the second quadrant. Agreed? So I know I'm in the second quadrant. I'm going to inverse the root of 3 on my calculator. What is tangent inverse of the root of 3? Ella? 60. So if that's 60, what is my angle? 120 degrees. What is 120 degrees in radians? 3. 2 pi over 3. So theta is 2 pi over 3. If you can't remember how to convert between radians and degrees, remember it is theta times pi divided by 180. That's the formula you use. So my final answer is R, which is 6, times the cosine of what? 2 pi over 3 plus what? I sine of 2 pi over 3. New, but I'm going to argue not that bad. Okay? Our last one, what do you notice is different here? Yeah, so we're going to call it 0 minus 2i.
Wouldn't there be a multiple where it would be undefined?
We'll talk about that. So I have R is equal to the square root of what plus what?
0 plus
Which is 2. Good. The R value is 2. That was easy. And then I set up tangent of theta is equal to what? What is 2 over 0? Undefined. So to bring to Easton's point, when is tangent undefined? 90 degrees or 270. Is that at 90 or is it at 270? 270 degrees. What is 270 in radians? 3 pi over 2.
Oh, if it's negative, like if that was like positive 2i, would that be 90 degrees then?
Yes, very good. So in this situation, you get 2 times the cosine of 3 pi over 2 plus I sine of 3 pi over 2. And I will show you one more time, because I think that this is cool, and I'm going to show you how to do the problem in 4 seconds instead of 2 minutes. Okay. So, first of all, the cosine of 270. What's the cosine of 270? 0. What is the sine of 270? So notice, if you were to turn this way, you get 2 times 0 plus negative I. And if you do that, you get to negative 2i, which is what you started with, right? It's a great way to always check your answer. Now, I told you that I would not do all this work to do that problem, because it's totally unnecessary. Are you ready? Oh, you want me to go back?
Oh, no.
You sure? You're feeling bad for me. Okay. All right. So, here's how I do the problem. I see negative 2i, and I plot it right there in my brain. What's the distance from there to 0? 2. What's that angle? Which is 3 pi over 2. And I am done. You see that? Like, you can visualize it, too. You see what I'm saying?
But what if we did that on the test?
That's, like, if you draw that and come up with that, you have 100%. Like, I have no problem. That's fine. There's multiple ways of figuring this out. I like to think of it visually. It helps me to work through it. So I would encourage you to sometimes think about that. Please take out your worksheet because there's some confusion on what we're doing. I try to design a good worksheet. Sometimes I don't do a good job.
What did we do yesterday?
Yesterday we did the first part, solving trig equations. We did more challenging ones.
This is the harder one?
So we did easy ones last Thursday. We did harder ones yesterday. Okay, so to be clear, so that you know what we're doing and the expectation and the directions, because people right away started placing these into trigonometric form. Did the directions say to place it in a trigonometric form? No, it says to graph it and find the modalist. How do we find the modalist? Which is square root of a squared plus b squared. So that's all you have to do for those front 8 or front 6. Then look at 7 and 8. Does it say to place them into trigonometric form? No. It simply says sketch z, which is that number right there and that number right there, and then sketch 2z. How does 2z compare to 1 plus i? What would 2z be? 2 plus 2i. And then you see the negative and the half. So just put all 4 of them kind of in that space. Get my point? And then when you flip it over to the back side, it says write the complex number in trigonometric form. Make sure your theta value is in radians between 0 and 2 pi. Does this say to place it into trigonometric form? Yes, it says place it in trigonometric form. Okay? Yep. So that's what you're going to do there. So that was the last 3 problems we did this. So this is the most important part of the assignment. It is posted. Do not fall behind. Do not fall behind. Make math a significant priority, please. This unit, especially if you miss a lot of days, it can be a very, very challenging piece. Today is the most important day for you to be here, though. It is the most important day for you to be here. So
you're recommending you'd rather have a star than not work on math.
what's that?
So you're saying that you'd rather have a star than not work on math.
Starve?
I feel like make math your absolute priority.
I don't think I said absolute. I think I said make it a priority.
Specifically,